Welcome to Chapter 4, Section 4.1, Angles and Their Measure. We are starting the trig portion of this course, and this first section has a lot of definitions. It's going to be a while before we can work some problems, so let's just go and learn these definitions, okay? A ray is a portion of a line made up of a point, we call the endpoint, and all points on the line on one side of the endpoint. So a ray would be something like this. An angle is formed by rotating a ray around its endpoint. So if I rotate it a little bit, I would have that, and the angle is formed there. The ray in its original position is called the initial side. This is the first one I drew, so it's the initial side. While the ray in its new position after the rotation is called the terminal side, which is right here. This point right here, the endpoint, is also called the vertex of the angle. Okay, now we do have positive and negative angles, and it all depends on the direction that you are rotating. If from your initial side, you rotate counterclockwise, that is a positive angle. And if we rotate clockwise, it is a negative angle. Okay, now, when we talk about rotating this way, so we have a positive angle, and we can maybe rotate a bunch of times and end up right back at the same side. Even though this beta would be a negative angle, alpha would be a positive angle, we end up with exactly the same terminal side. So we say that those angles are coterminal. Okay? An angle in a rectangular coordinate system is said to be in standard position if its vertex is at the origin and its initial side is the positive x-axis. Okay, so right here on this image, the terminal side is in quadrant 2, and we are rotating this way, so that angle is negative. If the terminal side of an angle in standard position lies on the x or y axis, then we say that angle is a quadrantal angle. Okay, so it doesn't lie in any particular quadrant, and here this angle rotates counterclockwise, so it is a positive angle, positive quadrantal angle. Okay, so if the terminal side of an angle lies in a quadrant rather than on a coordinate axis, we say that the angle lies in that particular quadrant. So here it appears that we are rotating counterclockwise, so it is a positive angle, and the terminal side is in quadrant 3. Okay. Now, a measure of 1 degree, denoted 1 with a little circle, is assigned to an angle resulting from a rotation of 1/360th of a complete rotation counterclockwise about the vertex. An angle formed by rotating the initial side counterclockwise 1 full rotation, so if we go all the way around and we end up right back where we started, then that has a measure of 360 degrees. And now some definitions. An acute angle measures between 0 and 90 degrees. A right angle measures precisely 90 degrees. An obtuse angle measures between 90 and 180 degrees. And a straight angle measures 180 degrees. So if we look at these examples here, you can see we have an example of an acute angle. This one's drawn to be 40 degrees, and if you see the little arrow here, it is rotating counterclockwise, so it is positive. This is a right angle of 90 degrees. It is rotating counterclockwise, so it is positive, and you see the little square here indicating that it is a right angle. An obtuse angle is somewhere between 90 degrees and a straight angle. Okay. Now here, an example of 540 degrees. Okay, so we are rotating counterclockwise. This is larger than 360, so we go all the way around once, And then if we go over to here, another 180 all the way over to here, you get 540. For this one, we have negative 300 degrees. We are rotating clockwise, and it rotates 90, 180, 270, not all the way up to 360, so it does lie in quadrant 1. And then the same kind of thing is happening here with 675 degrees. You're just rotating around multiple times. So you are going to have some problems where they just ask you to draw each angle in standard position. So if I wanted to draw the 150 degree angle, let's just think it's positive, so I'll be rotating counterclockwise. If I start here, then to go to here would be 90, and to here would be 180. So my angle has to lie somewhere in quadrant 2. And this is just an estimate, but it would look something like this. And you do want to indicate the direction of rotation. So that is roughly a 150 degree angle. Okay. If I want to graph negative 330 degree angle, I'm rotating clockwise. So from here to here would be 90, 180, 270, not quite to 360. It's going to be an angle like this. It is in the first quadrant, and we do want to indicate the direction of rotation, and it is clockwise.